Hello, Mike. This is my lab assignment for the protein synthesis, and with me today that is going to be learning the lab, it's my husband, and our friend is Norlax. Okay, so today we're going to be talking about protein synthesis. The protein synthesis happens on a cellular level. Basically happens in two parts of the cell, which is the nucleus and the ribosome. Everything in our body is made out of proteins, and the DNA is the blueprint to build those proteins. So the DNA is composed of 4 basic proteins, which are adenine, guanine, thymine, and cytosine. The adenine and the guanine, they are composed of 2 base rings called purine, and the thymine and the cytosine, they are composed of 1 ring called pyrimidine. So what happens, the first step in the protein synthesis is the transcription. The transcription is basically a copy of a template of our DNA. So this is our DNA here, 2 strains, and this is our template strain. So an enzyme called helicase is gonna come and open our DNA so that the mRNA can be formed. With the help of another enzyme called RNA polymerase, the RNA is gonna begin its copy. So what happens is an exact copy of the DNA is gonna be built in a single strain of RNA. So the DNA is going to be transcribed into this strain with only one difference. Instead of having thymine in our RNA, we're going to have uracil, which is another protein. So we're going to replace the T by the U. So those are the letters that compose the DNA. You're going to build them in the exact same order. So if this is adenine, here's supposed to be uracil, which is a U. So you can go ahead and build the mRNA, and if you need any help, I'm here to help you. So we have already separated all the proteins and the letters here, and you can go ahead and build our mRNA. We went ahead and we already built our mRNA here. So we copied everything, and for the purposes of the mRNA only, we didn't put 2 rings in the adenine or the guanine. We only used 1 ring each, but we know that they have 2 rings. Now, what happens later after this part is that the mRNA, it's gonna leave the nucleus and it's gonna move to the ribosomes. The ribosomes are the factory of the cell. So, as I said before, everything in our body, basically everything in our body, is built out of proteins. What I didn't say is that proteins are long chains of amino acids, and you actually don't have to copy the whole DNA to build a protein that you want. So for example, let's say you want to make more hair. Your body is going to look into your DNA to find the part of the DNA that is responsible, that has the blueprint of the color of your hair, the protein that builds the color of your hair. The helicase is going to open that part of your DNA, and our mRNA is going to be built in that part. It's going to be copied from that part. The mRNA also copies a lot of things before and after the part that it needs. because since it's a single strain, it dissolves with time. So that's why it has to have useless things before and after the actual protein. So let's start building our protein. What happens is the ribosome is going to read this strain in groups of 3, looking for the starting codon. A codon is a group of 3 letters. So it's gonna start, the starting codon is the AUG, and what's gonna happen is that the ribosome is gonna look for the starting codon, which is the AUG. Tá muito repetitivo isso, depois a gente corta. So you're gonna pass, is this AUG? Is this AUG? Is this AUG? And when it starts, it's when it starts actually building the protein. So now we're gonna build a protein. You're gonna look for the groups of 3, and after it starts, it actually goes 3 and 3. It doesn't go one by one anymore. So I'm gonna help you with that. We have our code list here of the amino acids we're gonna use to build our protein, and we're gonna use about 5 or 6 amino acids. Our protein is gonna be very short. It's gonna have about 5. So we're gonna start building our protein now. And the way the protein is built is that the ribosome is gonna read the mRNA looking for codons, which are groups of 3 letters each. And the way the protein is built is that the tRNA is gonna carry the amino acids and is gonna drop the amino acids into the ribosome, so the protein is built. And how do the tRNAs know where they have to leave the proteins? So the tRNAs have a code called the anticodon, which is basically the inverse of the letters that we have. So our starting codon is AUG. So the tRNA that has the anticodon for that, which is supposed to be UAC, carries the amino acid that's going to start our protein, which is always methionine. This is always a starting codon. Our body, we have 20 types of amino acids in our body, so we're probably going to repeat those amino acids throughout our protein. Start building our protein now. So the first one is AUG. You have to look for the starting codon. Okay. And now you have to look in our table for the amino acid that represents the starting codon. That's it. We have it here. That's the right amino acid, and so that's the first amino acid in our protein. I just like to remember that the protein is gonna connect. One amino acid connects in the other one. They don't actually go into a string or anything like that. They connect each other. So now we can look for our next codon. So after AUG, the next 3-letter group is
GUA.
GUA. So you can look it there. And you're gonna repeat that process until you find one of the 3 ending codons. The 3 ending codons are UAA, UAG, and UGA. Now for the ending codons, we don't have an amino acid. What is gonna happen is that we're gonna have almost like a giant building block that is gonna go there and stop our protein. And it's gonna end our protein. That's how our protein is gonna end. Protein is ready. This is our stopping amino acid, so what puts an end to our chain, and it was the UAA, the last codon here. And as you can see, we still have more things going on after that, but we're not gonna use that because, as I said, since it's a single strand, this is gonna be dissolved with time. What happens when this last amino acid is put in our protein is that it's gonna break the ribosome apart, the protein is gonna fold itself, and it's gonna be released into our cell for its specific function. The reason why it folds is that every protein in our body has a specific shape, and shape is equal function. So it has to have that specific shape for it to function. Before we finish, we're gonna take a look at mutations. So if we are exposed to X-rays or something like that, or sometimes our DNA makes a mistake. Our body makes a mistake when we are replicating our DNA, because as much as we check for it to be perfect, we can still make mistakes, right? Because we are doing that a lot of times. So if we have a mistake, we might have mutations. Now we have two types of mutations in our body. One is the point mutation and frame shift mutation. The point mutation occurs when one of the amino acids might be substituted. So what happens is, in our DNA, in our template strain, one of the letters is substituted by another letter. So for example here, if we look here, for example, let's say that this letter A, which is adenine, it's actually substituted by thymine. So let's say our adenine here is actually substituted by a thymine. So that means that during the transcription phase, when the mRNA was being built, we actually didn't have a uracil here in this position. We had an adenine. What happens is we're gonna have to look at our codons again. So we have AUG here, and then we have GAA instead of GUA, and that may or may not alter the order of our amino acids here. It might change the amino acid that's gonna be in this position. So we're gonna have to look at our table. So now that we have already changed our amino acid in our protein chain due to the mutation that our DNA suffered, our protein is not the same anymore. So it's probably not gonna have the same function anymore as well. So if we removed this letter, we're gonna remove it from our mRNA as well. And what happens is that now our codon is different. So we have the starting codon here, AUG, and our next codon, it's not gonna be GAA anymore or any other. It's going to be GAC. So our entire protein is gonna change now, and that's what the change that we're gonna make. So now we've changed our protein. Here's our new protein now. All the amino acids have changed because all of our codons have changed as well. So this is not the same protein anymore. This is completely different, and as we can see here, it doesn't have the ending codon anymore. So because we lost one of our letters there, we don't have an ending codon anymore. So this would keep going on and on and on and on. And that's really bad for our body as well.